students. Today we are going to learn the measurement of time and a simple pendulum. In offices and home, we commonly use a pendulum clock to note the time, which is based on periodic oscillations of a pendulum. The pendulum used in a clock is an example of a compound pendulum. Here, we shall study the principle of a simple pendulum. A simple pendulum is a heavy point mass suspended from a rigid support by a massless and inextensible string. When the freely suspended pendulum is at rest, this position of the bob is called mean position or rest position, and the position of the bob at maximum distance from the mean position is called extreme position. There are two extreme positions on either side of the mean position. Now, when the bob is disturbed to one end and releases, it produces a to and fro motion. One complete to and fro motion of the bob of the pendulum is called one oscillation. So, the type of motion produced by the pendulum is called oscillatory motion. The string of the pendulum is suspended from a rigid support, and the distance between the point of suspension to the center of the bob is called length of the pendulum. And the maximum displacement of the pendulum, that is, the displacement between the mean position and one extreme position, is called amplitude of the pendulum. The amplitude is denoted by the letter A and is measured in meter. The time taken by an oscillating pendulum to make one complete oscillation is called time period. It is denoted by the letter T, and its unit is second. Now, the number of oscillations made by the pendulum in 1 second is called frequency of oscillation. The unit of frequency in a SI system is hertz, or it is second inverse. If T is the time period of a simple pendulum and F is the frequency, then the time period T is related to the frequency F by the equation F is equal to 1 by T or T is equal to 1 by F. The time period of a simple pendulum is an important factor since the pendulum is related to the measurement of time. So, to measure the time period of a simple pendulum, the bob is slightly displaced from its rest position and is then released. So, it begins to move to and fro about its mean position O in a vertical plane along with the string. The time T for 20 complete oscillations is measured with the help of a stopwatch and then divided T by 20 to get the time period capital T. This experiment is then repeated for different value of lengths of the pendulum, and the observations are recorded in a table. From this observation, it can be noted that if the length of the pendulum is made 4 times, the period of oscillations get doubled, or we can say that the time period T is directly proportional to the square root of length, or the term L by T square is always a constant. If a graph is plotted For the square of the time period t square taken along y-axis against the length L taken on x-axis, it comes out to be a straight line inclined to the x-axis as shown in figure. This shows that t square is always directly proportional to L. If you take the slope of the graph, it is found that the value of the slope is a constant and is equal to 4 pi square by g, where g is the acceleration due to gravity at that place. Hence, g can be determined at the place from these measurements by using the relation g is equal to 4 pi square by slope of the graph. Now, let us look the factors affecting the time period of a simple pendulum. The time period of oscillation of a simple pendulum is directly proportional to the square root of effective length. That is, t square is proportional to L, or t is proportional to root of L. The time period of oscillation is inversely proportional to the square root of acceleration due to gravity, or t square is proportional to 1 by root g. Hence, we can combine these two relations and form an equation which is the time period of oscillation of the pendulum is given by t is equal to 2 pi root of L by g, or t square is equal to 4 pi square into L by g, where t is the time period, L is the effective length of the pendulum, and g is the acceleration due to gravity. At a given place, since g is constant, the time period of a pendulum of given length is constant. This is why a pendulum can be used to measure time. The time period of oscillation does not depend on the mass or material of the bob. It also does not depend on the extent of swing on either side or amplitude. Now, if a pendulum is having a time period which is equal to 2 seconds, it is known as a seconds pendulum. So, the pendulum with a time period of oscillation equal to 2 seconds is known as seconds pendulum. In such pendulum, the effective length is nearly 1 meter if the value of g at that place is 9.8 meter per second square. These are the main points related to simple pendulum. Hope you all understood all the terms correctly. Thank you and have a nice day.